Today there are 40 live operator commercial deployments around the world and a total of 53 public commitments from operators. And there are plenty more contracts and deployments in the pipeline beyond that. In the last quarter alone, we've seen new commercial deployments by Vodafone in Portugal, in the last week by Hutchison 3G in the UK. We've seen femtocells as the centre of a new mobile strategy from Free in France. We've seen a new deployment in a regional operator in Mosaic Telecom, showing that femtocells can work for even small operators. We've seen the world's first deployment commercially of an LTE femtocell offering by SK Telecom in Korea, of course. We've seen further deployment commitments from Telefonica O2 and from the Telenor Group. So a technology that's established and is scaling, with many of those networks in the hundreds of thousands, beyond 500,000, showing that upward capability. In terms of numbers, we were able to announce last year that there were already more 3G femtocells in the world than 3G macro cells. As a result of the forecasts that we're sharing today, we now see that in the course of this year, there will be more femtocells than macro cells globally for all technologies combined. So I think that's interesting that there is a significant number of femtocells out there, and our vendor members here will be pleased that that volume is continuing to increase. But I think even more significant is the fact that that means the shape, the topology of mobile networks really has already changed as a result of the advent of femto technology, and is set to continue to change more and more radically over time, as you can see when you compare the volumes of femtocells and macro cells. But it's more than just femtocells, and given our name change and our evolved scope, there is a wider story that I want to share with you. Femto technology has evolved from the deployment of femtocells. It is the collection of standards, of chipsets, of open interfaces, and of collective know-how that makes mobile broadband scalable and cost-effective and delivering a better user experience. And it turns out those attributes of scalability and ability to use any existing backhaul, those attributes are useful well beyond the home and small office environments that those cells were originally created for. So we now span whether those cells are user deployed in the home or the office, deployed by enterprise IT personnel in enterprises of course, or indeed deployed by operators. And these different application areas require very different deployment models, different types of backhaul, different form factors and so on. But they have in common this thread of this scalable underlying femto technology, which we're keen to make the very best of. A great particular example of that is around the opportunity for small cells in LTE. We've seen that operators pretty much universally see a role for small cells in LTE. We've seen surveys suggesting that 60% of operators see small cells as more important to their future LTE deployments than traditional macro cells. And that on the right there, when asked to rate the business impact of the features of LTE Advanced, small cells and heterogeneous networks generally are ranked as far and away the most important capability. In supporting that need, we've published interfaces that enable the different chips that make up an LTE small cell to work nicely together from different vendors. And we were able to announce that the key silicon vendors, people like TI, Broadcom, Mindspeed and others, and many access point vendors, have adopted those interfaces in their products. And those interfaces are already today in the world's first commercial deployment of LTE in South Korea. So when we think about those wider small cells, we start to think about the balance of numbers between them and the sort of home turf of femtocells. And the growth that Informa are projecting over the 5 years amounts to about a 20 times increase in the number of small cells, from around 3 million in 2012 to over 60 million by 2016. The impact of that will be that at that stage, small cells collectively will constitute nearly 90% of all base stations globally. I had high hopes for femtocells when we started Femto Forum back in 2007, but I really didn't imagine that we'd be able to say that we could see the point where most base stations were small cells, that they were the predominant form of delivering mobile service over that time scale. And I think that's a really significant outcome that we can point to today. Femtocells will continue to dominate in terms of the units, but clearly there is a wider business opportunity. So we're seeing increasingly that vendors and the products you see in these showcases are getting the cross-fertilization between the two. They're moving forwards in the enterprise and the residential environments, and then they're using that technology in the outdoor small cells and the public and rural spaces as well. So two elements of the business that are feeding each other very productively. And of course there are small cells out there in the wild today. There are many small cells, but increasingly we're going to see that the next generation of picocells and outdoor small cells will be of a style that leverages that femto technology very strongly. So as a forum, we work across all of these small cells. But of course there are other ways for operators to deliver mobile broadband services, and there are technologies adjacent to licensed spectrum small cells that we need to take note of. And a great example of that is Wi-Fi. We've pointed out over recent years that we see a great complementary opportunity for femtocells and small cells generally and Wi-Fi. But we're sharing some news this morning which goes well beyond just that complementary nature. For the last year we've been researching the possibilities of actually combining together small cell and Wi-Fi networks, not just in the access points, so you'll see examples of products emerging which have both femtocell and Wi-Fi capability in one box. It's not just that. Deep in the heart of the network, operators have the opportunity to bring together the way that they manage services across both of those platforms, to deliver data over those two bit pipes, if you will, to the end user flexibly and controllably to suit the traffic and the services that they're providing. And beyond that, to actually have both of those bearers delivering service to a single user at the same time, blending together the high speeds, the low cost of delivery, the difference in the quality of service between those two platforms, and to join those up. We've recognised in that white paper that there are a bunch of different technological approaches from different bodies, 3GPP, Wi-Fi Alliance, and many others that the industry is using under a general heading of carrier Wi-Fi there. But there is a real need, and we're setting out an agenda today for bringing those initiatives together, making them more productive and more efficient using the combination of Wi-Fi with small cells. And that means that this becomes not just offloading traffic, but it becomes the opportunity to manage traffic in a smart, fine-grained fashion to suit the user, the device, and the application that you're offering. Another announcement today. When we look at deployments around the world commercially of femtocells, about a third of those include a component that is specific to business users. So it's intended for use in offices, or it's deployed to business customers specifically. But in most people's minds, that's intended for use when you're working at home or working in a small office environment. And perhaps, using that in offices of 10 or 15 or 20 people. It was important for us as a forum to explore how scalable those approaches were, and whether we could bring femtocells and picocells enabled by femto technology to bigger and bigger office environments. And we've looked at the detailed radio issues necessary to enable that. So in a larger office you need femtocells to cover a bigger area, to have a bigger capacity, and to allow smooth transitions of users from cell to cell as they move around, and between those cells and the outdoor network as they transition in and out of the office. What we've identified in this guideline set out today is that there is a set of techniques that vendors can and are implementing in their cells which enable that interaction to work very well, and a set of simple deployment guidelines in actually how you install and plan these systems. Those guidelines, it turns out, are simple enough that they don't require trained radio engineers coming from the operator. They can be followed by enterprise IT personnel so that they can deploy a robust licensed spectrum network using broadly the same kind of skills they would use for deploying a robust enterprise Wi-Fi network today, meaning that small cells are scalable through the vast majority of office buildings, most of which are not the mega enterprises which operators are able to target today, but span the vastly more numerous office buildings with 100, 200, 500 people even, which is most offices. And operators today have had no real way of addressing those locations. It hasn't been cost effective to put in the distributed antenna and other RF specialty type of architectures. This provides a really enterprise friendly way of providing great mobile services into enterprises. And then the fourth of the areas of news that I want to share with you concerns the applications and services opportunities presented by small cells. So small cells clearly deliver great coverage, great capacity and a great user experience in a cost-effective fashion. But we've also seen in surveying consumers that the majority of consumers are interested in femtocells, but also that amongst those interested in femtocells, the vast majority see an interest in extra services that are enabled specifically by those. Services that mean that when you walk into your home, your phone does different things, it accesses different applications than would be sensible in the rest of the network. And furthermore, they're prepared to pay for that. So it provides an opportunity for operators to monetize these services, and increasingly we see markets where there are multiple operators offering small cells to consumers, and they want to differentiate those services, and this provides another way of doing that. As a forum, we need to enable that opportunity, and there are two prongs to that. One is specifications, so that applications can work across multiple small cells and multiple developers can develop them. And secondly, that developers understand about these opportunities and have the tools and the processes to enable that. Before today, we've made a number of announcements around that. We published the first APIs to enable small cell enablement of applications, and we worked with Broadband Forum to publish management standards so that operators could enable these APIs for the end developers. These APIs are already being implemented in operator-driven services, and just last week we announced a collaboration with OMA to take the APIs we've defined and turn them into fully fledged standards. However, to date, the engagement between operators and developers has been really with specialist developers who they've had to bring up to speed on the small cell technology and work very closely with them. And we want a much broader and richer set of developers to engage with this. So today we are launching our mobile developer community, giving this wider development community all of the tools to start creating those apps. Those resources include a developer forum where they can engage with each other, access to the APIs themselves, specifications and tutorials around that, and a fully fledged emulator that allows them to run code, to actually exercise these APIs and work in a sandbox to try things out before being exposed to the full glare of an operational mobile network. These have already been used by operators like Telecom Italia, working with vendors to demonstrate applications, which we had demonstrated around our booth yesterday. Up in Hall 7 you can find many other examples being demonstrated, and indeed across a wide range of the stands that our vendor members have, we have other applications there. For more information, we have this developer forum launched on our website this morning, which you can gain access to right now, see videos of those applications, gain access yourselves to the tools and the specifications that are necessary for those exciting applications. And this sets out the locations where you can find, and feel free to take these leaflets, where you can find more of those applications. So in summary, femtocells are well established commercially today around the world. And as an indicator of that, there will be more femtocells in the course of this year than conventional base stations across all mobile technologies combined. The technology, femto technology as we call it, that is emerged from those scalable deployments commercially is now powering this wider range of small cells, whether it be picocells, microcells, metro cells, or call them what you will. And that will power this further evolution of mobile networks so that nearly 90% of base stations by 2016 will be small cells. The combination of those small cells with Wi-Fi technology provides a huge opportunity for operators to manage traffic and service in a rich fashion, to access all devices, supporting all technologies in all locations. We've seen that femtocells scale from small offices right the way up to the largest enterprises, so that homes, public buildings and private buildings can all benefit from that technology in a scalable fashion. And lastly, developers can now access this rich set of resources to develop their own small cell enabled applications. That's our news. What I'd now like to do is pass to my colleagues to my left and give them a chance to spend a couple of minutes developing some of the themes I've mentioned and then sharing some of their company-specific news. First of all,